Okay, we're talking about absolute extrema in this section here. We've got the function f of x equal to x raised to the 2/3 power, and we're on the interval between -1 and 1. I should say the closed interval. And what we're going to do here is we're going to look at another possibility of the definition of a critical number. Remember, in an earlier problem, we were focusing mainly on this part of the definition. Now we're going to go if f is not differentiable at x equals c. Yeah, that's what we're going to do. Okay, so remember, I follow the step where first we find all critical numbers. And so what we're going to do here is take the derivative, remember. Actually, before I move on here, so you can see this, f is not differentiable at c. Then c is a critical number of f. But, okay, let's move on now. Alright, we have f of x is equal to x raised to the 2/3 power. We're going to take the derivative. That means you take the 2/3, bring it out front, and subtract 1 from the 2/3, which gives us a -1/3. And I'm going to actually write it in this form here so you can kind of better see it. So back to that definition. Okay, well, first off, there isn't anything that we can plug into this that gives us 0 out. And so we say that there's no real solution exists. Don't worry about the real part, just no real solution exists. But I want to go back to the definition real quick. Okay. It says if f is not differentiable at c, then c is a critical number of f. If it's not differentiable at c, in other words, not differentiable at c means that we're going to let c equal 0. Okay, so we can't plug 0 into this. It's undefined. Can't plug 0 into this, into our derivative here. It's undefined there, so it's not differentiable at 0. All right, that's it. Simple as that. That's the and of course the only number it's not differentiable at, even on the entire real number line. All right, well, let's work our way down. So we say that f of x is not differentiable at f prime 0. Therefore, this 0 here is a critical number. Okay, it's not differentiable at 0. Therefore, 0 is a critical number. Now, we have to also remember we're inside of this closed interval. Okay, we're inside the closed interval. So you got to kind of be careful, especially when we run into things like vertical asymptotes. But we have to be inside of a closed interval. All right. Anyway, okay, well, let's move down. Okay, so I go ahead and state the function back up here again so we can see what's going on. So now that we've found our critical number, what we need to do now is just plug our endpoints in. And we get 1, and we plug -1 in, we get 1, plug 1 in, we also get 1. Now remember, this is our critical number. We plug 0 into this, and we get 0 out. So in this particular case, we get two maximums, two separate points on the graph. Okay, and this is where the maximum, absolute maximum, occurs. And of course, this is going to be our minimum here. And we just label it 0, 0. Now let's look at the graph. Okay, so this is the graph. Now this line right here, orange, and it's not orange for any real particular reason. It should be this color here. But what I have found is on a number of graphing calculators and so forth, and that is that for some reason it doesn't want to graph this side, and that it has to do with negative under the square root, but don't worry about that. Okay. So you can see the absolute max is occurring here and here, and the min is occurring, absolute min is occurring down here.